Every year, 6.5 million deaths are being recorded globally. And this can be attributed to air pollution, increased air pollution and environmental degradation. So good afternoon all. In my presentation today, I'm going to talk to you about the future of shale gas markets in the United Kingdom. Okay, so I'll show you a map that was culled from the World Health Organization that shows the high mortality rate due to air pollution. And due to this climate change issues, the UK government has set a long-term goal to slash down carbon dioxide emission by 60% by the year 2050. And we can see that they are clearly on track with this carbon budget. So basically, natural gas produces over 1/3 of all the energy that is being consumed in the United Kingdom. But as the supply of this conventional natural gas became lesser than its demand, shale gas became the next alternative fuel source. So this shale gas is a natural gas that is found within shale, in shale formation. So basically, the shale revolution in the United States has led to the dramatic reduction in the price of natural gas, as we all know, and it's made a couple of people lost their job, basically. So this shale revolution has led to the reduction of price, and basically novel technologies to help improve and optimize the production of shale gas is now a significant area of global interest. But to optimize production, it is very important to understand the behavior of fluid mixtures that are confined in shale gas. However, there is still an unsatisfactory understanding in the behavior of this shale chemistry. This is why I recently carried out a research project that was aimed at providing a detailed characterization of the behavior of fluid mixtures that are confined in shale gas. This project was sponsored by Shale United Kingdom, and the reason why they were interested in this topic is that the methodological approach that was adopted for this work can be used to run real-life simulations, and also some valuable implications that were proposed can be used for reservoir engineering calculations. The topic was thermodynamics of fluid mixtures confined in shale gas, and so some of the methodological approach was basically using empty data, which is a thermodynamic software, and to run the simulation validation for thermodynamic prediction of different shale reservoirs. So basically 5 different shale reservoirs have been explored for these studies in the United States. We've got the back-end shale and so on. So I'd share a few of the research findings with you due to time constraint. So basically simulations were ran for heavy hydrocarbons and light hydrocarbons. So we've got methane, ethane, butane, and so on. And it was realized that heavy hydrocarbons actually interact more with the pore walls. That's the inner shale walls of the rock, while the lighter hydrocarbons sat right in the middle of the reservoir. So this can be attributed to the fact that the heavy hydrocarbons has a longer branch chain, so they tend to interact with the pore walls of the shale rock, compared to the lighter hydrocarbons like CH4, which has a relatively very short branch chain, because it's just CH, H, and H down, if some of you know what I mean. And also carbon dioxide is quite dense, so it just sits right in the middle of the reservoir also. Okay, so another case study was a case where I ran simulation in confined space and in an unconfined space. So basically, from the graph that I'm supposed to be showing, in confined space, a higher yield of gas productivity was seen, while in an unconfined space, you tend to see it was in 3.5 kilogram, and in a confined space, it was right about 5.0 kilogram. And this was in back-end region, which is in the North Dakota in the United States. So another case study was the pressure effect on Eagle Ford's shale gas reservoir. Nice, nothing is showing. Okay, so these are prospective areas of shale gas deposits found in the UK. So we've got the Wessex Basin in Winchester. We've got the Stafford Basin in Staffordshire, Cheshire, which is in Chestertown. We've got Pennine, which is where the Boland Shale sits. And we've also got the Weald Basin. Which is in the eastern part of England, and a British exploration company called iGas actually did a critical assessment and a critical study and concluded that there's over 15.1 trillion cubic feet to 172.5 trillion cubic feet of volume of gas sitting right beneath the UK. So, I mean, it's evident that the UK is not willing to back down from this industry. So it's very, very evident that they're going to, because shale gas has prospects in the United Kingdom, and definitely they're going to want to keep exploring this. I'm sure a lot of people know that fracking is the misconception on fracking is a major issue in the United Kingdom. So Schlumberger and a few environmental agencies have actually carried out a critical assessment, and they've concluded that fracking poses no pollution damage or even to the environmental groundwaters, that's the underlying aquifers. So there's nothing like pollution damage. It can't cause the earthquakes that the public actually has a misconception about. And I strongly support the shale gas exploration in the United Kingdom, as this might just be a brilliant step change in the right direction. Thank you very much, and I'm sorry the slides are not showing.